Tech Nuggets, IPv4 Subnetting, Part 2. In the previous video, I went over a variety of rules for subnetting, why you might need to know it, what some of the basics were. If you haven't watched it, I highly recommend that you go watch it, as it will lay out all the basics of the background necessary to understand what we're going to do in this. This video is going to be an example of how to use block diagramming to do a subnet example subnetting. In the notes below, I have listed a link to a PDF that will be very useful, as it covers and has a layout of a variety of things that you might need. It will also have all the block diagrams at the end, but at the beginning it will have basically IP documentation that will be very similar or the same as to what we're talking about, and that way you can sort of follow along. If you've got a second monitor or something like that, you can follow along looking at the slides, and I'll try to call out the pages of the slides so we all know where we are as we go along. Block diagram subnetting. So using the rules we know, we're going to use a block diagram to lay out the subnet and learn to start subnetting. We're given the network allocation of 10.200.5.0/24. So we've got 256 addresses in total, and we're assuming that they're giving that to us from our ISP or from whoever our network provider is, and those are the IP addresses we have to work with. In our situation, we're going to work with a smaller network, and the tools that we learn here, though, will work for much bigger networks, but it'll be easier to work with a /24 as sort of a good starting point. So we'll be on page 1 of our PDF that will lay out in sort of a documentation style what we're looking at here on the page, and the two are equivalent in terms of what they represent. And I will go over the diagram here now. So at the top, we're going to have our network number, which is represented in the red. And you'll notice I've only shown the last number, right? We call that an octet, as it's represented by 8 bits. So I've only shown the .0. So all the numbers that we're working with here, 10.200.5, they're all part of that number, but we're only showing the last number. It's part of the reason we use the /24, and it makes it a little easier to work with and doesn't clutter up our diagram so much. Again, if you're looking at page 1, you'll see that it lays out all the different information with all the numbers in it. So we get the size of the network and the usable address, and it lays out the usable range, and even gives you the dotted decimal subnet mask along with the binary, if that's kind of what you want. In our case, we're looking at a /24, so we've got network numbers that go across the top in red, we've got broadcast addresses that go across the bottom in blue, and we've got our / notation for our subnet mask here in the middle. And our network numbers will always be in red in the upper left, and our broadcast addresses will always be in blue in the lower line. The green lines represent the boundaries of our subnet. So in this case, we're a /24, and that means we'll be going from 0 to 255. That is, in fact, 256 values, as 0 is a legitimate value. A lot of people have asked, well, wait a minute, you said it was 256. 0 is a legitimate value, so that means we go from 0 to 255, which is 256 values. So we'll want to keep that in mind when we do subnetting, because we'll see that 0 number, or we'll see that concept of why do you count that. That's why. All right, so the first thing we're going to do that is the binary rule that we talked about earlier in the rules. We must divide our subnets in half, equal halves. So that's what I've done. Drawn a line right down the middle. We're still on page 1, basically, because I haven't laid out all the other information, but we've divided it in half. And here you can see I've added the documentation. If we change our PDF to page 2, you can see that documentation keeps up with it. We've now got 2 network numbers. We've got 0, which is still a network number, but now the broadcast address for that subnet has changed on the left half. So we go from 0 to 127, which is 128 values, giving us a /25. Think of it like a 50-cent piece in our dollar analogy. On the top, we now have a new network number, which is 128, and it goes to 255, which again is 128 values, giving us 2 /25s. We had to take our network. It had to be divided in half. That's part of the binary rules. We're going to continue to subnet down to try to show how we can subnet the subnet and continue to get more useful, smaller networks as we go. So So if we change to page 3, we'll see that we've taken one side, so one of our /25s, and we've divided that in half. So now I have two /26s. One goes from 128 to 191. The other one goes from 192 to 255. This gives us two smaller networks and one larger network. Remember when we said we make change, it doesn't matter, we can make change with different size coins. And in this case, that's what we're doing. Our /25 is very similar to a 50-cent piece, whereas our /26s are much more like quarters. Please also note that as we subnet, those numbers go up. So every time I divide a network in half, the subnet mask gets a little bit bigger. In fact, it gets one bigger. So we take a 24, we turn it into two /25s. That means we added one to the subnet mask to get smaller networks. It seems kind of counterintuitive, has to do with the math and the binary that I won't bore you with, but if you want to know why that is the way it is, got to go look at the math. So this is page 3. We can see we've got 3 networks. We're going to do the same thing. We're going to take our last /25 and we're going to divide it into two 26s. So if we look at page 4, we can see all of it divides out. We've got 4 equal size networks in this case, where we've got basically 4 quarters in our dollar analogy. We took a dollar, we divided it into 50-cent pieces. We took that and divided those into 2 quarters each, and we get 4 nice sized networks each that are size 64 IP addresses. Remember, with N-2 rule, those will be 62 usable IP addresses. And so we lose all the numbers that we're seeing on the slide here, where those are our N-2 numbers. So we're going to lose those, and that means our networks get less and less. We get less usable addresses than we started with because of the N-2 rule. So what happens if my business need means I need different sizes of networks? I need different things. So we're going to cover a little bit of that, not in great gory detail, but a little bit. We're going to go back to page 3 as our starting point. So I've got a /25, 2 /26s, and I need to do something more with one of the 26s, but I don't want to lose more addresses than I have to. I don't have to slash up the other networks. So we're going to take one of our /26s and we're going to divide it into even smaller networks. So if we flip to page 5 in the PDF, we'll see that I took one of my /26s and I made it even smaller. So now we took a /26, which is 64 addresses, and I cut those in half and made 2 size 32 networks. So I go from 192 to 223 and 224 to 255. And while my analogy for money kind of breaks down here, /26s were like quarters, /27s, there's no such thing, at least in US currency, as a 12.5-cent piece. So my analogy for money kind of breaks down at this point. But it's still useful for working with subnetting and as an analogy for that. All right. Several great tools exist, both on the web. So we can use it in a normal size web browser. We can use it on our phone. You can search for subnet calculators that will help generate the information that's in the PDFs so that you can start with wherever you are in your subnets and start chopping and hacking. I highly recommend the visual subnetting tool, which I've linked at the bottom here. It's a great tool. It does very similar things with the block diagrams, but you can put in great big networks and poke buttons and get it to divide it up. We'll show you very similar information. I use it when I do subnetting because it does a great job. There's page 6, and this is mostly for my students, but it can also be for people working a job that need to do some quick subnetting. When it comes to subnetting, I tend to remember the /24 because there's a lot of mental gymnastics that go with subnetting. I've created this mental cheat sheet that's on page 6. I've also put it in as a slide here next. The fact is, for a quiz or a test, you can't bring it with you. That's cheating. However, I can derive what I need on site. Grab a blank piece of paper, write down the one thing you can remember, and start deriving from there. And in this case, I've highlighted it and put it in red, the /24. I can remember that a /24 is 256 addresses. And if we can remember the simple rules that every time I divide the network in half, I add 1 to the slash notation, so 124 divides into 2 /25s, and they're each size 128. Some of the other information I put out here, just so that you can have it, the mask dotted and notes fields, or so that you can remember it, But when I sit down in an exam or I need to do some quick subnetting, I can remember that a /24 is 256. And I can just sit and write /24, /25, /26, and write all the way down to 32. And then I can write 256 next to the 24 and start dividing it in half. 256, 128, 64, 32. When I'm done, I've got a pretty nice cheat sheet that wasn't really cheating because I derived it there on site in the exam or the test. And it's also the kind of thing I can remember when I'm working with colleagues and I need to try to remember what is a /29. They keep talking about it and I can't remember how big is it. Is it a 16? Is it a 4? I can sit and quick write that down. I hope you enjoyed this Tech Nugget. It's worked out really well for a lot of my students in the past. I'm hoping that you've derived value from this. Come on back, we'll have more Tech Nuggets in the future.